In these two examples, we're going to look at writing the claim as a mathematical statement. We'll state the null and alternative hypothesis and identify which one represents the claim. So let's look at the first one. A tablet manufacturer claims that the mean life for the battery for a certain model of tablet is more than 8 hours. Let's look for some key phrases in here. First of all, we're looking at the mean life. This means that we're looking at mu. The next key phrase I see is more than. In math, how can we represent more than? We can use a greater than sign, and is more than 8 hours. Now, this will be part of one of the hypotheses. Let's look at the complement. The complement is going to be the opposite. Now, notice here that in my greater than sign, I'm not including 8. Therefore, whenever in the complement, I will include 8. So this means it's not just going to be less than, but it's going to be less than or equal to. Now, since this first one has the equal sign in it, that's going to be my null hypothesis. And this one with the greater than sign will be my alternative hypothesis. And we can state that this alternative is the claim. Okay, now let's look at the second one. According to a recent survey, 73% of college students did not use student loans to pay for college. So let's look again for the key phrases. We're looking at 73%, so this means we're looking at a proportion. And it's not giving me any clues as to is more than, less than, at least. It's just saying 73% of the college students did not use student loans. It's a finite number. They're saying they either did or did not use student loans. Therefore, this is going to be equals to 0.73. Okay, did not use student loans, so 73% of college students did not use student loans to pay off for college. The complement is going to be the opposite. So here you have equals, the complement is going to be not equals. And we just got through stating that this one actually was the claim because we took what was given here and we wrote it as a mathematical statement. Now let's determine which one is the null and which one is the alternative. The one with the equal sign is going to be the null hypothesis. And therefore the one with the not equal sign, or the inequality, meaning it's not equal, is the alternative. In this next example, we're talking about type 1 and type 2 errors. Describe the type 1 and type 2 errors for a hypothesis test of the indicated claim. A used textbook selling website claims that at least 60% of its new customers will return to buy their next textbook. Let's quickly look at some definitions of type 1 and type 2 errors. A type 1 error occurs if the null hypothesis is rejected when it is true. A type 2 error occurs if the null hypothesis is not rejected when it is false. So to work this problem, or to figure out what the type 1 and type 2 errors are, let's see if we can first form some hypotheses for this example. It says a used textbook selling website claims that at least 60% of its new customers will return to buy their next textbook. Let's represent at least using a mathematical symbol. At least is bigger than or equal to. And since I'm dealing with a percentage, I can rest assured that this is a P, or proportion. What's the complement of greater than or equal to? Less than. So the one that includes, or the one that has the equal sign, is going to be my null hypothesis, and the other will be my alternative hypothesis. Now let's look at this in terms of the type 1 and type 2 errors. Remember that the type 1 error occurs if the null hypothesis is rejected when it is true. This means that we would reject the null hypothesis, but yet the null hypothesis is true. Therefore, the answer is a type 1 error will occur when the actual proportion of new customers who return to buy their next textbook is at least 0.60, but you reject the null hypothesis. Next, let's look at the type 2 error. Remember that in a type 2 error, the null hypothesis is not rejected when it is false. So how would you write this in words? You would say, a type 2 error will occur when the actual proportion of new customers who return to buy their next textbook is less than 0.60, but you fail to reject the null hypothesis. In this next little segment, we're going to talk about left-tailed, right-tailed, and two-tailed tests. A test is left-tailed, right-tailed, or two-tailed based on the mathematical sign that's in the alternative hypothesis. So when you're trying to decide if a test is left-tailed, right-tailed, or two-tailed, look at the sign or the mathematical sign in your alternative hypothesis. If in your alternative hypothesis you have a less than sign, this is going to be a left-tailed test. And if you were to sketch this on your normal curve, you would be shading area to the left, and that would be your p-value, which we'll talk about later. If your alternative hypothesis has a greater than sign, this is going to be a right-tailed test. And if we were to look at our normal curve, we would plot somewhere on the right side, and we would shade the area to the right. And if our alternative hypothesis has a not equal to sign, this is a two-tailed test. We would have one on each side. So let's look at an example of what we just talked about. State the null and alternative hypothesis, then determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. Sketch a normal sampling distribution and shade the area for the p-value. A security expert claims that at least 14% of all homeowners have a home security alarm. Here's your key phrase, at least 14%. How can you represent at least mathematically? That is a greater than or equal to sign. Since I'm dealing with percentage, I know that I'm dealing with a proportion, and the complement to greater than or equal to is less than. The one that has the equal sign is going to be my null hypothesis, and the one that does not, or has the inequality, is the alternative. Now, is this a left-tailed, right-tailed, or two-tailed? To find that out, look at the mathematical sign or the mathematical inequality sign in your alternative hypothesis. Since it is a less than sign, this is going to be a left-tailed test. So if I were to look at it on a normal curve, it would be somewhere over here, and I would shade to the left, and this would be my p-value. Now, when we're doing hypothesis tests, it's very important that we can take our results and interpret them. So in the following example, we're going to first determine whether the claim represents the null hypothesis or the alternative hypothesis, and then we're going to see how we would interpret our results if we reject the null hypothesis or if we fail to reject the null hypothesis. A scientist claims that the mean incubation period for swan eggs is less than 40 days. Let's look at this. Less than gives us a key to know what mathematical sign we're working with. Less than 40 days. And since we're talking about the mean, we're going to use mu. Now notice here that This sign does not include equality. It does not include the equal part. Therefore, we know that this would be the alternative hypothesis. So the claim is represented by the alternative hypothesis. Now the next thing we want to do is we want to know, how should we interpret our results? In part A, if we reject the null hypothesis, how are we to interpret those results? Well, if we reject the null hypothesis, we're basically accepting the claim, because remember that the claim is the alternative. So if you reject the null, you're saying that the alternative is true. So in words, we would say, there is enough evidence to support the scientist's claim that the mean incubation period for swan eggs is less than 40 days. Let's look at part B. What happens if we fail to reject the null hypothesis? If we fail to reject the null hypothesis, it's like we're saying the null hypothesis is true, and the null hypothesis is exactly the opposite of the scientist's claim. So how would we put this in words? In words, we would say that there is not enough evidence to support the scientist's claim that the mean incubation period for swan eggs is less than 40 days.